I'm Hoed. I'm a senior lecturer in pyrometallurgy in the School of Chemical Metallurgical Engineering. I got here not by design but purely by chance, hence my comment earlier about the vagaries of life. At school I was interested in chemistry. It started when it was in my second form year, we grew crystals, and that's what captivated me. So actually I wanted to read chemistry at university. But people say your job prospects are better in engineering, why not do chemical engineering? So that's how I got into chemical engineering. That's the degree that I read. In second year, I thought, oops, this is engineering. I'm really more interested in fundamental reactions and chemistry. But you pursue, I got my degree. I wanted to do research. Research is what interested me. So I stayed on and started a master's program. And the project that I was given, the problem that I was given, was the reduction of ilmenite. Ilmenite is an iron titanium oxide that South Africa, together with Australia, produces half of the world's supply of ilmenite. It's the supply of titanium, which is used sometimes for metal, but principally as a pigment. So all of the paints that you see, Cremora has titanium dioxide pigment in it. And it was studying the reaction, what we call the kinetics, in other words, the mechanism and the rates of reaction, and the thermodynamics, in other words, what's possible. When things react, what do you form? And then I found that I was going back to what I was really interested in. To me, that was chemistry. All right, it was a metallurgical problem, but it was essentially chemistry and looking at reactions and thermodynamics. And that pretty much set me on my career. I joined Mintech as a researcher. I was at Anglo Research for a period, and it was only, again, the vagaries of life, the slump in commodity prices in 2009 meant that mining companies pulled back. There was a huge retrenchment exercise, and I found that half of us at Anglo Research were retrenched. And it was the former head of school, Chemical Metallurgical Engineering, who said, I want you to apply for the position. And here I have to say, I ticked all the wrong boxes. I was old, I was white, I was a male, and I wasn't qualified. But I got the job. And I tell people that I found it extremely rewarding at the end of my career. I have less than 6 months to go to retirement, and it's been extremely rewarding. So that's my journey. That's a very interesting question. It's a huge challenge. It's a challenge because of a generation difference, and along with the generation difference, a cultural difference. And with that mixed in is, today I spoke about Gen Z, and I read a lot about what motivates this generation. And the things that motivate young people today are different from what motivated me when I was younger in my generation. But the other difference is what young people bring to the university today is different from what I brought to the university. I would say, and partly because what I didn't mention is, yes, I was trained as a chemical engineer, practice as a metallurgical engineer, but I'm actually a cognitive archaeologist for more years than I'm on both of those. And to me, it's not so much about what you do, but I'll qualify that at the end. It's about the skills that you bring to solving the problems that we face in society today. And we face, I think, bigger problems, life-threatening for humanity today than we ever did before. I grew up in the Cold War, and there was this tension between the Soviet Union and the West, the United States. Would we all be obliterated in a nuclear war? Well, in hindsight, I don't think that could have happened, because human beings were touching the buttons that could have brought an end, and common sense prevailed. We cannot control climate change. We thought we could, but actually we can't unless we change our lifestyle, reduce our CO2 emissions, and then the microplastics and a lot of other things. And to tackle those problems, you need first In material science, it will help you, one, metallurgical engineering, how we use waste, how we reuse materials, understanding properties, developing new materials that do not depend on materials that are harmful to the environment, things like that. You have to have that explicit knowledge. But in order to utilize that knowledge, you need to know how to think. You need to know how to construct arguments. You need to know how to put your finger on the problem, to ask the significant, important questions. That's the role of a university. It's not explicitly taught. I believe it's picked up by, in the program, the problems that one works through, the exercises that one works through, projects and such like. You begin to see from lecturers, from your classmates, how to tackle problems. But really, that's the goal of the university, is to teach young people how to think, this critical thinking, because that will allow you to take the explicit knowledge, work it to solve the problems.